Okay, my name is Brittany Kiger, and I'm going to be going over what I did for my individual project for DBST 652-9041. So let me get into presentation mode. So task 1 asks us to review the legacy database, which you can see here below. You can see that it includes the guardians are in a man and a woman table, and they both are connected by the DOM, which would be their date of marriage, and that goes down to where their child branches into the man and woman, and underneath child shows sibling pairs. So for task 1, a little bit of detail. It says that for the data fields, most of the fields are not null. Only the wife ID and the date of marriage fields in the table man and the maiden name field and woman and the father ID and mother ID fields in the table child are allowed to have missing data, i.e. nulls. So it's not much nulls. The primary keys, man ID, woman ID, and child ID are just simple primary keys for the man, woman, and child tables respectively. Child 1 and child 2 are a composite primary key for the sibling pair table. There will be multiple indexes as well. There's an index for the last name and first name, which is the composite index for man, child, and woman. Father ID is a simple index for the child, and mother ID is a simple index for the child. There is an index for the date of birth on the child table, and wife ID is a simple secondary index for table man. This prevents multiple men from identifying the same woman as their wife. So there's also some data validation rules. First name and last names have to be longer than 2. Maiden names can be blank. If it's blank, then it must have a length of at least 2. Gender is either female or male. No dates can be in the future for birth dates or marriages, obviously. Man, woman, child IDs have to be greater than 1001. And if wife ID is blank, then the date of marriage must also be blank. If wife ID is not blank, then date of marriage must also be non-blank. And a child does not have to have a father. A child does not have to have a mother, but every child must have at least one parent. So task 2 asks us to review the new requirements, which change the table to be that guardians are referenced as guardian 1 and guardian 2. There's no gender assigned to guardians. It allows children to have 1, 2, or more than 2 guardians. It requires siblings to have at least one common guardian, but different second guardians. Provide guardians with a description, so you can define whether that person's their mother, father, step parent, legal guardian. Task 3 asks which of the items I plan to discard and which I would like to keep. So I no longer have 2 different guardian tables. There would be one guardian table, but I do want to allow for multiple guardians to a child, so the guardians would just be associated that way. Excuse me. Also, they are no longer defined by gender. I decided that would be an option, but it's not required because some people in this age do not identify with a certain gender, so I left that open. I'm going to still store the first name, last name, ID, date of birth, status, which I won't. I'm going to eventually have a check that is for single or married. Description, like called out in the previous. So you could say if they were a guardian, father, mother, whatever. And the date of marriage. All the fields will not be allowed nulls except for the date of marriage, since this does not apply to all guardians. And in the child table, I'm storing the first name, last name, ID, gender, date of birth, and I'll have a foreign key to the guardian. All fields are required except for gender. My reasoning for this is that some children may not identify as a certain gender, as I stated previously. For the sibling table, child ID is used. And for this table, a sibling pair will have at least one common guardian. So for my primary keys, for each table, we'll have simple fields. So each is a guardian ID, child ID, and the sibling ID is just a composite key for child ID 1 and child ID 2. I created some indexes to improve performance. I am going to keep the idea for the composite index for a guardian. So it will be last name and first name, but I have also opted to include the date of birth in the guardian and child one. And the child one is last name, first name, and then obviously date of birth. And guardian ID will also be an index for the child table. Data validation. So we'll need many different validation rules to ensure data quality. I'm keeping the name check where the first names and last names have to be longer than at least 2. I'm getting rid of the gender constraint mentioned above. I have that as an option, but it's not required. I will be keeping a check on the date of birth and date of month to ensure the dates are in the future. Date of marriage is not required. I also opted to create sequences for children and guardians, so validation doesn't have to be outlined for those. If the status is single, then the date of marriage must be blank. If the status is married, then the date of marriage must not be null. The child does not need multiple guardians. However, there must be at least one guardian assigned to a child. Some extra things I added. Oh, excuse me. There will be one guardian table, and I intend to allow for multiple guardians to a child, and they will not be required to have a relationship between the guardians. And gender is no longer required. All fields are not allowing null except for the date of marriage and gender. For the sibling table, child ID is used. A sibling pair will have at least one common guardian. I'll be creating sequences for the child and guardian. I didn't see that in the previous examples. And then I added the check that if status is single, then date of marriage must be blank. And if the status is married, then the date of marriage must not be null. And a child does not need multiple guardians. So task 5 asks us to create the logical and relational models. So here's my logical model below, which explains everything that I talked about in the previous things. You can see that there's one guardian table, one child table, and one sibling pair. Excuse me. And you can see the foreign key exists here for the guardian ID, and the foreign key exists here for the child. So there's 2 different childs for a composite key for primary and for primary key and foreign keys here. In the relational model, you can see a little bit more, such as the data types I went with on here. And you can still see the relationships and the foreign keys here as well. The last task was to create DDL. I did use the data modeler to auto-generate my DDL from my models, and then I manually added the indexes, constraints, and sequences. You can look at that information in the DDL file as requested. I did enjoy this project. I feel like it was a good learning opportunity.